Rate of change actually is just more general than that of the slope of a line. So a slope of a line is actually an example of a rate of change, but rate of change just more generally is just looking at really kind of the speed, which is just really another word for rate, at which some sort of a quantity changes in relation to another. So you're just kind of comparing two different things, might be like temperature and time or whatever it might be, and seeing how those two things change in relation to one another. So one simple example in which we can see that is in the relationship with the trees right here. So we want to be able to find the average rate of change in the diameter of this tree. And so we see that it was 141 inches in 2020, and then previous to that, it was 137 inches in 1980. So to find the average rate of change in that, we want to be able to compare really the inches in diameter with the time. And so if we find, first of all, the change in the diameter, we can do so by subtracting and finding the difference, which of course is going to be a 4-inch change. And then also finding the change in time, which ends up being a 40-year difference. So when you have 4 over 40, you can reduce that, of course. Now your label, since I had inches on top and years on bottom, is like inches per year then. So it does turn out that this right here would be the average rate of change, and emphasis on the word average right there. Because we're saying on average, it changed 1/10 of an inch per year. That does not mean that it always changed exactly 1/10 of an inch per year, because in 1 year, it might have changed by, let's say, 0.13 inches in a year, and then in the next, it might have done like 8/100ths, etc. So in this example right here, we have that Eliza is driving from home to go back to college. At 10 a.m., she's 195 miles from home, and at 3 p.m., she is 520 miles from home. What is the average rate of change of her distance from home over time? So we want to be able to compare distance and time to be able to find a rate of change. So let's find the change in distance. So we know that she was 195 miles from home, and then she was 520 miles from home. So if we did do 520 minus 195, that's going to give you the change in distance over time. But then also, this was at like 3 p.m. and this was at 10 a.m., but we don't want to use 3 and 10 because with like times, right, it's not going to work out so well. So really, you're just going to have to find kind of the change to go from 10 a.m. to 3 p.m., and that turns out to actually be a change of 5 hours of time. So what we end up getting out of that then is we end up getting 325 miles of change over 5 hours of time. And then if you divide that out, it ends up giving you 65, and then it would be miles per hour. So that's telling you the average rate of change, which really is just like the speed she was traveling over time. Again, it's just an average, so she's not necessarily always traveling 65. It's just the average of when she was going like 68 at one point, and then 55 another, etc. Just averages out to be 65 miles per hour.